Sir, I am P. Lokesh Sagma from CCC section. Today I am discussing about ionic polarization. Subject name Physics. Subject code 23PHY01. Ionic polarization. We can define ionic polarization as the ionic polarization occurs when atoms form molecules and it is mainly due to relative displacement of the atomic components of the molecule in the presence of electric field. Or ionic polarization can be defined as it is due to displacement of ions and cations in opposite directions and occurs in ionic materials. Example, NaCl placed in external electric field. We can see in the diagram when electric field is not applied, cation and anion. In the presence of electric field, the cation and anion can be polarized. Let us consider plus m and minus m are the masses of the positive and negative ions respectively. When the electric field E is applied on an electric dielectric, then positive ions get displaced in the direction of applied electric field through x1 units and negative ions displaced through a distance of x2 as shown in figure. Hence, the next distance between two ions X equal to x1 plus x2. If E is the electronic charge of any of the ions, then ionic displacement mu I equal to Ex. It can be equation 1. That simply mu I equal to E into x1 plus x2. Equation 2. Due to the applied field, the force is exerted on charge carriers. Therefore, the force due to applied field F equal to E into capital E. This can be equation 3. When ions are displaced, the restoring force appears on the ions that try to make x1 and x2 equal to 0. Under equilibrium conditions, force due to applied field should be equal to restoring force. The restoring force acting on ions is F equal to K1 x1 equal to K2 x2. This is equation 4. Equating equation 3 and equation 4 where K1 and K2 are force constants. Small e into capital E equal to Kx. K1 equal to m omega naught square. K2 equal to capital M omega naught square, where omega naught is angular velocity of the ions. Equating equation 3 and equation 4. Capital into small e equal to K1 x1 equal to K2 x2. That simply K1 x1 equal to capital E into small e. That simply x1 equal to small into capital E by capital M. This is equation 5. And K2 x2 equal to small into capital E. X2 equal to small into capital E by K2. Therefore, x2 equal to small into capital E by m omega naught square. This is equation 6. Substituting equation 5 and 6 in equation 2, we get mu I equal to small e into small e capital E by m omega naught square plus small e capital E by small m omega naught square. Thus simply mu I equal to small e into capital E by capital M omega naught square plus small e into capital E by small m omega naught square. That simply mu I equal to E square into capital E by omega naught square into 1 by capital M plus 1 by small m. This is equation 7. But we have dielectric movement mu proportional to electric field capital E. Mu directly proportional to capital E. That simply mu equal to alpha I into E. Therefore, alpha E equal to mu I by E. That simply alpha I equal to mu I by E. This is equation 8. Substituting equation 7 in equation 8, we can get alpha equal to E square capital E by omega naught square into 1 by capital M plus 1 by small m divided by capital E. Therefore, E can get cancelled and we can get alpha I equal to E square by small m omega naught square into 1 by capital M plus 1 by small m. Thus, ionic polarizability alpha I is inversely proportional to the square of the natural frequency of the ionic molecule and can be reduced mass, which is equal to 1 by capital M plus 1 by small m whole inverse. Applications and advantages. Ionic polarization enhances the dielectric strength of materials, making them suitable for high voltage applications in capacitors and insulators. It plays a crucial role in the performance of ferroelectric materials, which are used in memory devices and sensors. The ability to manipulate ionic polarization allows for the design of materials with tailored properties, improving efficiency in electronic components. We can see in the diagram with no applied electric field, the answer displays separately. With applied electric fields, the ions are moving towards each other. Overview of ionic polarization. Ionic polarization occurs when an electric field distorts the electron cloud of ions in a material, leading to temporary dipole formation. This phenomenon is significant in various dielectric materials, affecting their electrical properties and capacitance. Understanding ionic polarization is essential for the development of advanced materials used in electronics and energy storage systems. Thank you, sir, for giving this opportunity.